Unit 2, Worksheet 3, Position versus Time Graphs. Problem 3, Part D. Determine the skater's average velocity from a time of 0 seconds to a time of 16 seconds. Average velocity is the displacement. Final position minus initial position divided by time elapsed. So when we're going to be calculating our average velocity, velocity is going to be represented with the lowercase v, and the mathematical way of representing something as an average is we can put a horizontal line above that variable. That's going to be represented by our change in position, represented by the letter x, over our change in time. Now the way that we can look at this is the final position, our position at the final time, minus our position at the initial time, over, well, that same time final minus time initial. Now the problem itself is telling us that we are ending up at 16 seconds, and we are starting at 0 seconds. So once we know that our times, we can use those times to figure out our positions. At a time of 16 seconds, we trace that up, looks like we have a position of 8 meters. So our final position is 8 meters, and our position at time 0 is going to be at the origin, 0 meters. So our change in position, that's displacement, it's 8 meters, and our change in time, or the time elapsed, is going to be 16 seconds. So we can write that as 1 meter every 2 seconds, or we can write it as our average velocity is going to be equal to 0.5 meters every 1 second. This is our average velocity. Problem 3E. Determine the skater's average speed from a time of 0 seconds to a time of 16 seconds. Average speed is the path length divided by the time elapsed. So I'm actually going to change up the color a little bit. I'm going to use green so that way we can go over our line a little bit. So our speed, we can represent with a letter S for right now. And if this is our average speed, I'm going to put that line above it, just like what we did for average velocity. Now the difference here, we're looking at something called the path length. This is the length of the path traveled over our change in time. So our path length, we're going to see just how far this skater traveled. In the first region of the graph, they started off at a position of 0 meters, and then in this region, they ended up traveling 4 meters. So far, the length of their path is 4 meters. From 4 to 6 seconds, they stayed at that same position, so they traveled a distance of 0 meters. So I add 0 meters to that. The next region of the graph, they went from a position of 4 meters to a position of 2 meters in those 4 seconds. So their position changed by minus 2 meters. However, they still traveled a distance of 2 meters. So I add 2 more meters to our path length. From 10 to 12 seconds, they stayed at that same position, so their distance didn't change. Add 0 more meters. And then from 12 to 16 seconds, they went from a position of 2 meters to a position of 8 meters. So they gained 6 more meters of distance. And they did all of that over our change in time of 16 seconds minus 0 seconds. The length of their path, 4 plus 0 plus 2 plus 0 plus 6, that's 12 meters over 16 seconds, which if we simplify that down, our average speed in this 16-second interval is going to be 0.75 meters for every 1 second. Now, there will be some times where our speed and our velocity will be the same magnitude, where it's going to be the same amount of change in position and change in distance over the same period of time. However, there are going to be cases, like the example with our skater who went from one position to an end position, and if that's all we're focusing on, that's average velocity. But if it's in this situation where the skater goes to a position, they stop, they come back, they stop, they go forward again, and they don't take a direct route between 2 points, your speed and your velocity that you have calculated might end up being different values. So it's okay if your average speed and your average velocity are not the same. Sometimes they will be, sometimes they won't. In this situation, if we only care about where our skater started and where they ended up and how long it took them to go between those 2 points, then we would be using velocity to measure that. It took that skater 0.5 meters for every 1 second to get to that final position of 8 meters. However, if we were more interested in the fact that the skater, went to the right, they stopped, they went to the left, they stopped, and then they went to the right to their final position, then we would be interested in looking at our speed to see how fast they're going over that period of time.